Hey guys, welcome back to the channel. So today I'll do a video on database table partitioning. So I'm going to show you with PostgreSQL how you can do basically database partitioning with different coverage. So I'm going to talk about the range method, the list method, the hashing method, the subpartitioning method, and the default partition methods. I'm going to show this with usable examples that you can replicate depending on your use case. Like the indexes video I made last time, which depending on if you have a database that is a SaaS versus a data lake or whatever, you might need different types of indexes. It's the same thing for partitioning. I invite you to look at that video somewhere in the cards here. You can find it, and it's going to greatly help you to jump in the partitioning video right after. So without further ado, we're going to talk about the range partitioning method. And this is mostly used with time-based data, or it could also be used with a column that is just a number that can go in specific ranges. But the example we're going to show today is basically a time-based example. So we simply have a table basically that is called events. And with that events table, what we're going to do is we're actually just going to do So with that table events, what we're going to do is we're going to have a ID, which is an automatically generated ID, a created add column, which we're going to be partitioning on, a user ID, and an event ID. So as you can see, the only thing that changes from declaring a normal table is just the partitioning by range and specifying which is the partition criteria. So if we create that just like this, it created our table, and then based on that partition, we could create a sub partition that basically stores only the first month based on the created at range by specifying create table, the name of that sub range, and then the partition of events, so linking back to the original table for the values of January 1st to February 1st. And this will give us the basically values stored into events 2026-01, which is the first month. So if we do that like this, and we can do the same thing for the second month, which is going to be February, just like this. It's pretty fast because we don't have any data in there. Now, let's insert some data just to show you guys how the partition pruning really makes it more efficient to run queries against your database. So in here, we're just going to insert some events into the events table, and we're going to use those for the first table, which is going to be our first partition, that is the first month. And we're just going to basically generate random users ID and random created at dates records with a random array of events into that table. And we're going to generate 20,000 of them. So if we run this like this, pretty instant. And then let's do the same thing, but for the second month, which is going to be February. So if we run this like this, again, it just worked. And now what we want to show is basically how the partition pruning works in that specific case, right? Like what is going to happen if we need to usually very recurringly filter by dates, right? Because in a analytics timestamp database, you basically want to be able to look at specific subset of data based on dates mostly. And you might also want to look at it, for only one day. But what will happen is instead of having to scan all those dates where there's million, even billions of rows, you will only have to scan a specific partition, right? You could partition by day if you wanted instead of by month or even by week or whatever you need. But in this case, we're going to show you with the explain analyze what's going to happen if you basically take leverage of the partition that is made on created at. So if we run this, we can see here we have the query plan that we've seen in the previous video about indexes. But basically what it does is instead of doing a sequential scan, which we've seen in the past is the most expensive querying you can do in a database, we basically only are doing sequential scans on the events 2026-02 table, which is the subset basically of February, right? So as we can see, we basically have a very low execution time because we're also only filtering, scanning one table that has the subset of our data, right? Compared to if we were to, do, let's say January 10th to February 20th, then we need to scan those two tables, right? Because we have basically two sequential scans that are appended together, and you can see that the latency is higher than before, right? So you could play with partitions based on what's your granularity needs, but in this case, you see that if we only partition, we only scan one partition, it's going to be way faster than going across partitions, which is always the goal, right? So that's for the basically the range partitioning, mostly for time-based stuff. Again, like I said, you could create a partition every day if you wanted. Just think about it in a way that the more partitions you create, the more subtables it create, and the more storage basically you need to be ingesting, because you need to store metadata for all those subtables, and there's also a limit of partitions you can create per table. So definitely based on your needs, make sure to check before. Now we're going to jump into the list partitioning. So that's the kind of use cases I would use for SaaS platforms. So I got some clients that would use, let's say, Supabase for a SaaS, and they want to do multi-tenant, right? So let's say I'm going to give a good example. Let's say Google, Meta, and Oracle are your basically your clients. You don't want their data to be basically used together, right? You only want to query one company every time. So what you would do is you would create a table, let's say for in this example, invoices, with an ID, a tenant ID, an amount of, let's say, for the invoice, and I created that timestamp, right? Now you notice that instead of partitioning by range, we're basically partitioning by list of the tenant ID, right? So each individual tenant ID will have its own partition, which makes sense, right? Because if you query only Oracle, you don't need to know what Meta does or what Google does, right? You only need that tenant's IDs rows inside that invoice table. So let's make an example here, and let's just create, let's say, the partitions for Acme and Globex, just so we can show examples. It's like this. Then let's actually insert some data in there to show you examples of what would happen if we query those two different partitions that are automatically generated based on the tenant ID. So let's just run these two together. So we inserted 7,000 rows. And then if we look in the demo, basically what will happen in the query planner is we'll see that we're only doing a sequential scan on invoices Acme section, right? So we're not actually querying the other partition, which is Globex, right? So there's multiple advantages to this. There's the privacy concern, right? So if you have a multi-tenant database, you don't want basically your other clients to be discoverable by another client that's not related, right? You want that separation in the database. So that prevents you from having to create multiple databases, but still keep one table, but just separate it at the, at the partition level. So again, you see your sequential scan on invoices, Acme, invoices, and then same thing if we were to do, Globex like we put here, it would only query the Globex invoices partition, also reducing the time, right? What we could also see is we could do in, and then we could do something like this, where we put both of them into the array, and we do Acme like this, and it's like this. So you'll see it's actually sequentially scanning both partitions, separately, and then appending the results. So again, there's multiple ways you can do this, but if you only want to get your company, let's say only Globex, you can select only the Globex partition. So I think that covers it for the list partition type. Now I want to go into the hash partitioning because this is especially useful if you want to, do a lot of writes pretty quick. So this could be used pretty well for a high throughput database. Like let's say you are, if you know Posthog, so Posthog is an analytics database, and let's say you need to capture thousands of events per second, and you need to write quickly into the database. Well, the ash partitioning is very efficient at this because it basically subsections your table into smaller pieces or smaller partitions that basically keeps integrity across your table very fast, right? So let's just run for this example, the creation of the table. So again, ID, user ID, page URL, view that. So that's a pretty standard table. Now, what we'll do is we'll basically check for each partitions of page views, we're basically going to do, we're going to group it by 4 page views per partition. So as you can see, the modulus is going to be our initial comparator, and then we're going to have the remainder, which is going to progressively increase. So it's going to reduce the size of the partition as we grow. So if we create those tables, you can see right here that we've created it. Now, if we insert into those data, so what we're going to do is we're going to insert the page views into our tables, and we'll basically generate 100,000 rows. And you can see it's going to be pretty quick. Like it took 0.37 seconds to insert 100,000 rows, which would have taken multiple seconds in a normal form, because this partition is basically cementing the ashes, right? So the ashes partition is really a big edge case. If you really need fast throughput, that would be a good use case. But for most application, you're better off with a range or a list methodology. So I wouldn't start with this one, but definitely dig more into it if you require that type of partitioning, because it can be useful for your use case. Now we're going to talk about subpartitioning. So this is basically combining the previous method we've done, so the range, and then ashing that range, right? So an ash lookup is way faster than actually, using simply searching for filtering that value based on something, right? So what you're actually doing when you're, ashing those in those specific tables is, since there's a lot of recurring values here, like a user ID or page URL and stuff like that, or viewed at whatever, since there's recurring values, it basically ashes it and it's faster to search, right? Because there's some basically similar ashes across those values, because you could have, let's say, a user ID that comes multiple times on the same page and triggers the same events. So you want to be able to find that user ID pretty quick across your analytics, table. So we inserted basically our data here. Now the subpartitioning plus, so basically includes range and ash, and we're going to show that with the metrics table that I'm going to create right now. So let's say you want to do reporting and you want to basically show, the kind of volume of page views per user, let's say per month. Then what you would do is you would do like we said. So you would set the partition by range, recorded that. And then what you would do is create a table for each month. So right here, so we create one for the first month, like we did before. So January 1st to February 1st. And then we also specify a subpartition that is by ash of the customer ID, because once again, we don't want to, keep all those customer grouped together, because we only need one customer if we're looking at a specific, page view profile of a customer. So if we create that table, you can see it's pretty fast, and then we can create those sub tables based on that metrics table. So it's going to group it by the customer ID, but also going to group it by a page number, right? So as you can see in there, we had a page URL page, so it's also going to group it by the page. So it's going to be faster to retrieve once we need to retrieve it. So let's just create those right here. And let's insert some data in there just to give us a data set to test. And then what you will see is that we're going to insert basically a few numbers. So the customer ID, metric value. So basically, let's say you have a conversion value of a customer visiting a page. and recorded at, so random dates, just like this. And what this will do is it will basically, every time you try to query the page views for a specific customer, it's gonna not only go into the customer's page value, but also in the customer's grouped partition, right? So I'm gonna show an example right after. And then we're gonna finish off with the default partition. So the default partition is mostly like a safety net. So if you don't want to, just have partitions for smaller customers that don't need data segmentation, what you would do is you could basically create a catch-all, a catch-all default partition. So instead of being partitioned by a value, then it's only partitioned by the rest of the values. So if we create an example, so let's create all those partitions like this, and the table. And now if we insert into the orders table, just like this, and then what we can do is look at the amount of orders it created, right? So as you can see, it basically created the size of partitions for us, queried the size of partition, sorry. So basically $995 US, $1,013 from Canada, and the rest is basically grouped into one giant bucket of default, which is almost 3,000. So it really shows us how basically you can create catch-all buckets if you don't need segmentation for a specific customer. A good way to think about this is, let's say you could set a script that checks if there's enough rows for a new partition to be created, and create a new partition if required for a specific, let's say, customer in one instance. So let's say a small company grows, and after a year they have a lot of invoices, so you need segmentation. You would create a new partition based on your analysis of the number of rows it has and the impact it has on the table querying. So that's a good thing to know in terms of default, if you don't want to, go with the headache of just creating like small partitions for every one of those. The thing is, you do need to know the values in advance if you want to create partitions for, specific countries. Let's say it's values, customer names that you don't know in advance, then it's harder to, create a partition in advance. So you would use the default, and then after maybe use a partition. So for the final partitioning, we're gonna basically just do a final inspection. So I'm gonna show you the partition size for different tables. So we're gonna check the events table. So as you can see, the tables are separated. So if you remember at the start, we added for some events for the month of January and then February. So you can see the segmentation of those rows in the bottom, which is 20,000, 30,000. So they're very separate. And then we could do another pruning example that I made just here that would show you what would happen if you query above or equal to February 1st. And as you can see, what it's doing is solely a sequential scan on the second table. So another example of what I just showed. But this is, the power of partitions. Basically, just make sure you choose the right one when you're doing your use case. In most cases, the range and list will be the one that you're going to use with a little bit of default partitioning. I'd say the hash and the subpartitioning are more advanced stuff, but definitely start looking with the range partitioning with the timestamp specifically, or number values, and the list also if you want to do it for multi-tenant SaaS. So if you have any other questions, feel free to leave them in the description. I can in the comments. I'll answer them as soon as I can.